Hello guys, in the previous tutorial we have built the Solana storage program, and now in this tutorial we will discuss the Solana program model in brief. Alright, as I said previously, Solana is stateless, which means it does not store the data in the program. Instead, it stores the data on something called as accounts. Programs are the backbone of Solana dApps. They define the working flow of applications. If you are familiar with Ethereum, you can think of them as smart contracts but upgradable. Yes, you can upgrade the program code anytime on Solana. The code that you write in the program is called instruction. The programs on Solana are stateless, meaning they cannot store the data like smart contracts. You have to define accounts in order to store the data. The programs are mostly developed using Rust or C++, but you can choose any language that targets the LLVM and BPF backend. Now let's talk about accounts. You can think of accounts as the files in operating system that holds the data. Some of the things about the account you should know that are as follows. The first one is accounts have fixed size. Once initialized, it cannot be changed further. The max size of account is 10 MB. Each account has a unique address. You have to pay rent in order to keep the account active. The default account owner is the system program. You can generate any number of accounts. Of course, there is more to this, but these things are enough to understand the account structure on Solana. There are three kinds of accounts on Solana. The first one is data accounts. They store the data. Second one is program accounts. They store the executable program. And the third one is native accounts. They are native programs on Solana such as system, stake, vote, etc. Data accounts can be of two types. The first one is system owned accounts and the second one is PDA, that is program derived address accounts. Each account contains the following information in it. The first one is Lampert, the balance of the account in Lamperts. The second one is owner, which will be the program owner of the account. Third one is executable, which specifies if the account can process the transaction or they are just to store the data. The next one is data. It's the raw data byte array stored by the account. And the last one is rent epoch. It is the next epoch the account should pay the rent. It may be a little bit confusing for you at this time, but that's the way Solana works. Let's understand the above account model on the program we are building, that is Solana storage program. This image over here explains our program structure. If you remember, we have declared init account where we are storing the actual value. Like this, you should define the accounts according to your data structure to store the data. Now let's talk about transactions. Anyone can interact with programs or accounts by submitting the transactions to the Solana cluster. A transaction can include multiple instructions, each targeting its own program. When a transaction is submitted, the Solana runtime will process its instruction in order and atomically. If any part of the instruction fails, then the entire transaction will fail. Normally, the transaction will contain the following information with it. The first one will be the array of all accounts it intends to read or write. Then the next one is one or more instructions. Then a recent block hash and one or more signatures. So that was all about the Solana program model. I guess you have got the overall idea of how Solana program works. You can definitely study further about Solana architecture from the documentation, but for now this information is sufficient to build our storage application. In the previous chapter we have already built a complete storage program. Now let's try to write the test cases for it. See you in the next tutorial.